Just as the mighty Tyrannosaurus rex ruled the land, the Megalodon, a massive prehistoric shark, ruled the oceans with unmatched power. It was so large and fierce that today's great white sharks look small next to it. With its enormous size and bone-crushing bite, the Megalodon was a true monster of the deep. Join us as we dive into the ocean and uncover the secrets of the Megalodon and what made it the ultimate predator of the seas. Megalodon, the greatest fish. The Megalodon, one of the most legendary predators of the ancient seas, lived in oceans worldwide, inhabiting both coastal and oceanic waters during the Miocene and Pliocene epochs, which began 23 million years ago. The Megalodon was undoubtedly renowned for its enormous size. Estimates of the Megalodon's length typically range from 50 to 70 feet, with some suggesting it could have grown even larger. In comparison with today's great white shark, which usually measures between 15 and 20 feet with the largest recorded individuals reaching up to 21 feet, it only means that a Megalodon was at least 2 to 3 times longer than the average great white shark. The Megalodon's impressive size extended to its other dimensions as well. The estimated breadth of a Megalodon's body was likely proportionally greater than that of a great white shark, contributing to a much more massive and robust frame. A great white shark's girth might measure around 12 to 15 feet, whereas a Megalodon's could have been closer to 30 feet. A fully grown Megalodon is estimated to have weighed between 50 and 70 tons, compared to the great white shark's maximum weight of around 2.5 tons. This staggering difference in weight highlights the Megalodon's immense physicality. The Megalodon's size gave it several advantages. Its massive body would have allowed it to store energy and travel long distances in search of food. The Megalodon likely targeted large marine mammals such as whales, seals, and giant sea turtles. The Megalodon had a relatively similar body shape to the great white shark, suggesting that it was a fast and efficient swimmer, but the Megalodon likely swam slower than today's great white shark due to its massive size and weight. However, it was still a powerful and efficient swimmer, capable of bursts of speed to ambush prey. Its strong tail and robust body enabled it to dominate the ancient oceans effectively. The exact coloration of the Megalodon is unknown, but it's speculated that, like many modern sharks, it may have had a countershaded coloration. This likely means a darker gray or blue-gray on top and a lighter, almost white underside, which would help it blend into the ocean environment from both above and below. Although scientists theorize the existence of the red Megalodon, believed to be 100 times more dangerous than the Megalodon from unique fossil discoveries showing reddish tooth pigments, this variance evolved camouflage enabling stealth in deep waters, and its presumed greater speed and versatility in hunting. The Megalodon's bones. The Megalodon's bones and internal structure are also quite fascinating. As with other sharks, the Megalodon skeleton was primarily composed of cartilage, making it lighter than bone and allowing the shark to swim long distances with less energy. The cartilaginous nature of the Megalodon skeleton likely had a significant impact on its behavior and physiology and would have contributed to exceptional swimming efficiency, allowing it to cover vast oceanic territories in search of prey and mating partners. The flexibility of cartilage may have also facilitated the Megalodon's agility and maneuverability, aiding in hunting and capturing fast-moving prey in the open ocean. However, this also means that much of what we know about Megalodons comes from their teeth, vertebrae, and fossilized poop, as cartilage is difficult to fossilize. The exact cause of the Megalodon's extinction remains uncertain, but factors such as climate change, competition for prey, and shifts in marine ecosystems likely played a role. The Megalodon's teeth. One of the most striking aspects of the Megalodon's size is its mouth and teeth, which are massive and can be bigger than a human hand. The Megalodon's jaws were approximately 9 to 11 feet wide, capable of swallowing large prey whole. Its teeth were triangular and could grow up to 7 inches long, significantly larger than great white shark teeth, which typically reach about 2.5 to 3 inches. The root of the tooth has a V-shaped notch at its base, and the enamel-covered crown has a rough, porous bone-like texture on the root, while the enamel is smooth and polished but sometimes broken by vertical cracks. The edges of the teeth are serrated like steak knives. The Megalodon used its teeth as a tool for breaking apart food that could have hard parts. Surviving in the chemically reactive environment of the mouth, the teeth were designed to be chemically and physically resistant to withstand these conditions and break apart prey. The Megalodon's bite force is estimated to have been between 24,000 and 40,000 pounds per square inch, far surpassing the great white shark's bite force of around 4,000 pounds per square inch. And in case you are wondering, the average human bite force is only 160 to 200 pounds per square inch, which compared to the Megalodon is infinitesimal. The powerful bite of the Megalodon allowed it to effortlessly crush the bones of its prey, including large whales. As an apex predator at the top of the ocean food chain, the Megalodon likely had a similar diet to the great white shark, feeding on other fish, seals, small whales, turtles, seabirds, and other marine mammals. Fossil marine mammal bones have been found with megalodon teeth, along with large bite marks attributed to the megalodon. Despite the remarkable attributes we've highlighted about the megalodon, it is astonishing to learn that during prehistoric eras, there existed creatures equally or even more perilous. These formidable beings could have posed significant challenges in the ocean comparable to those of the fearsome megalodon. Well, let's explore a few of these awe-inspiring adversaries. Number 10. Tylosaurus. The Tylosaurus, a formidable marine reptile of the late Cretaceous period, swam the ancient seas approximately 85 to 70 million years ago. Belonging to the group of marine reptiles known as mosasaurs, Tylosaurus was among the largest predators of its time, reigning as an apex predator in the late Cretaceous oceans. Tylosaurus was truly impressive, with estimates suggesting lengths of up to 39 to 40 feet. Its long, sleek body, powerful flippers, and large tail fin enabled it to move swiftly through the water, pursuing prey with remarkable agility. The structure of Tylosaurus was characteristic of mosasaurs, with a streamlined body, a long snout filled with sharp teeth, and powerful jaws capable of delivering devastating bites. Its body was covered in smooth, overlapping scales, providing both protection and hydrodynamic efficiency for life in the water. Tylosaurus was a carnivorous predator, feeding primarily on fish, squid, and other marine creatures. Its streamlined body and powerful swimming abilities allowed it to chase down fast-moving prey, while its sharp teeth and strong jaws enabled it to dispatch prey with ease. The fossils of Tylosaurus were first discovered during the 1870s in the United States. Since then, numerous specimens have been found in various locations across North America, including Kansas, South Dakota, and Texas, providing valuable insights into the anatomy, ecology, and behavior of this ancient marine predator. Despite its fearsome appearance and predatory prowess, Tylosaurus, just like every other prehistoric animal on this list, eventually faced extinction, mostly due to changes in marine ecosystems or competition from other apex predators. Number 9. Livyatan. Named after the biblical sea monster, Livyatan was a colossal marine predator that prowled the oceans during the Miocene epoch, around 12 to 13 million years ago. Fossils of Livyatan were discovered in 2008 in the Pisco Formation of Peru by a team led by paleontologist Olivier Lambert. The discovery included a well-preserved skull and partial skeleton, providing valuable insights into the anatomy and lifestyle of this ancient marine predator. The Livyatan was an apex predator with a formidable size and hunting capabilities that potentially rivaled megalodons for dominance. Livyatan was relatively huge, reaching lengths up to 56 feet and weighing an estimated 50 to 60 metric tons. Its skull alone measured around 3 meters, which is approximately 10 feet in length, housing enormous teeth that could grow up to 36 centimeters in length. These teeth, along with a powerful bite force, allowed it to dispatch prey with ease. Livyatan was likely a voracious carnivore, feeding on a variety of marine creatures including fish, seals, and even other whales. Its hunting style likely involved ambushing unsuspecting prey, utilizing its speed and agility to deliver devastating attacks. However, scientists discovered that while the megalodon was a shark, the Livyatan was a mammal, belonging to the same family as modern sperm whales. This distinction influenced their hunting strategies and ecological roles. While the megalodon relied on its razor-sharp teeth and powerful bite to incapacitate prey, the Livyatan may have used a combination of brute force and cunning tactics to subdue its victims. And if there was ever a fight between the two marine kings, well, we can only imagine who would have won. Number 8. Ichthyosaurus. The Ichthyosaurus, meaning fish lizard, was a fascinating marine reptile that inhabited the ancient seas during the early Jurassic period, approximately 200 to 190 million years ago. While both Ichthyosaurus and Basilosaurus have the term saurus in their names, which means lizard in Greek, they are actually quite different creatures, belonging to different evolutionary lineages. Ichthyosaurus was a dolphin-like creature that belonged to the group of marine reptiles known as ichthyosaurs, and was among the most successful and abundant predators of its time. The fossils of Ichthyosaurus were first discovered in the early 19th century in England. Mariana, a pioneering fossil hunter, unearthed the first complete specimens of Ichthyosaurus along the Jurassic coast of Dorset, England, in the early 19th century. Ichthyosaurus was moderately large, with adults typically reaching lengths of around 6.5 to 13 feet. Its streamlined body, elongated snout, and powerful tail enabled it to move swiftly through the water in pursuit of prey. The structure of Ichthyosaurus was adapted for a life of marine predation, with a fusiform body shape, for flippers for propulsion, and a large tail fin for steering. Its eyes were large and well-developed, indicating adaptations for hunting in low-light conditions. Ichthyosaurus fed primarily on fish, squid, and other small marine creatures. Its sharp teeth and streamlined body allowed it to catch and consume prey with efficiency, making it a formidable hunter of the ancient seas. Now it's time for today's topic. Crew members from a private expedition operating near San Juan Islands say they witnessed something that left even veteran divers speechless. While surveying the waters of the Salish Sea, a dorsal fin surfaced less than 50 meters from their boat, far taller and thicker than any recorded great white in the region. One diver pointed in disbelief as the massive body rolled just beneath the surface, revealing scars and a girth they claim exceeded anything previously documented. The footage, now circulating online, shows the shark pacing their vessel before disappearing into deeper water toward the Strait of Juan de Fuca. Marine biologists remain cautious, but the divers insist it was no ordinary predator. Some whisper the unthinkable. Could this be evidence of something long believed extinct? Number 7. Dunkleosteus. The structure of Dunkleosteus was characterized by its heavily armored exterior, which provided protection against potential predators and rivals. Its large, powerful jaws were capable of delivering devastating bites, thanks to the presence of sharp, interlocking bony plates known as fangs. Dunkleosteus prowled the waters during the late Devonian period, approximately 360 to 380 million years ago. This prehistoric fish, belonging to the class Placodermi, was among the largest creatures of its time. Dunkleosteus was truly massive, with estimates suggesting lengths of up to 20 to 33 feet and weights of several tons. Its elongated body, covered in thick bony armor plates, and powerful jaws equipped with sharp, serrated bony plates made it a formidable apex predator. Dunkleosteus was a carnivorous predator, feeding primarily on smaller fish and other marine creatures. Its powerful jaws and sharp fang-like teeth would have enabled it to tear through flesh and bone, making quick work of its prey. The fossils of Dunkleosteus were first discovered in the mid-19th century during the 1830s in what is now modern-day Ohio, United States. These initial discoveries included partial skeletons and fragments of the armored plates that characterized Dunkleosteus. Since then, additional specimens have been found in various locations around the world, contributing to our understanding of this ancient apex predator and the ancient ecosystems of the late Devonian period. Number 6. Archelon. The Archelon, meaning ruler turtle, was a remarkable giant sea turtle that inhabited the oceans during the late Cretaceous period, approximately 70 to 65 million years ago. This enormous marine reptile belonged to the group of prehistoric sea turtles known as Protostegidae, and was among the largest turtles to have ever lived. The Archelon was truly massive, with estimates suggesting lengths of up to 15 to 18 feet and weights of several metric tons. Its size rivaled that of modern-day leatherback sea turtles, making it one of the largest marine reptiles of its time. The structure of Archelon was adapted for a life of marine existence, with a streamlined body, flipper-like limbs for swimming, and a large, flat shell for protection. Its shell, which could reach lengths of over 13 feet, provided both defense against predators and buoyancy for life in the water. Archelon was likely an herbivorous or omnivorous feeder, feeding primarily on a diet of seaweed, algae, and other marine vegetation. Its broad, flat beak and powerful jaws would have enabled it to crush and consume plant material efficiently. Archelon's hunting behavior likely involved foraging for food along the seabed or in shallow coastal waters, using its keen sense of smell and vision to locate prey. Its large size and armored shell would have provided protection against potential predators, allowing it to feed relatively undisturbed. The fossils of Archelon were first discovered in the late 19th century in Kansas, United States. Since then, additional specimens have been discovered in various locations around the world, including North America and Europe, contributing to our understanding of this ancient marine reptile. Archelon is related to modern-day turtles, as it belongs to the broader group of turtles known as testudines. However, Archelon is more closely related to sea turtles than to terrestrial or freshwater turtles. Number 5. Sarcosuchus. The Sarcosuchus, often dubbed the supercroc, was a massive crocodilian that roamed the Earth during the early Cretaceous period, approximately 112 million years ago. This massive predator belonged to the family Phyllodosauridea, and is considered one of the largest crocodiliforms to have ever existed. Sarcosuchus was truly gargantuan, with estimates suggesting lengths of up to 36 to 39 feet and weights of around 8 to 10 metric tons. Its bulk, jaws equipped with rows of sharp teeth, made it a fearsome predator of its time. The structure of Sarcosuchus resembled that of modern crocodiles, with a long, streamlined body, powerful limbs, and a large, elongated skull filled with conical teeth. Sarcosuchus was likely an opportunistic predator, feeding on a variety of prey including fish, turtles, small dinosaurs, and other terrestrial animals that ventured too close to the water's edge. Its powerful jaws and robust physique would have allowed it to capture and dispatch prey with relative ease. Sarcosuchus likely employed ambush hunting tactics, lurking beneath the surface of the water and striking with lightning speed when unsuspecting prey approached. The fossils of Sarcosuchus were first discovered in the mid-20th century, specifically in the Sahara Desert region of North Africa, during expeditions led by French paleontologist Albert Félix de Lapparent and his team in the 1940s and 1950s. Recent research has revealed similarities between Sarcosuchus and modern crocodiles in terms of their skeletal structure, indicating shared evolutionary traits. Additionally, studies suggest that Sarcosuchus may have had a similar lifestyle to modern crocodiles, including basking in the sun to regulate body temperature and utilizing aquatic environments for hunting and reproduction. However, its significantly larger size and potential differences in behavior and ecology set it apart from its modern counterparts. Number 4. Basilosaurus. The Basilosaurus, whose name means king lizard, was a remarkable ancient marine mammal that lived during the late Eocene epoch, approximately 40 to 34 million years ago. Despite its name, Basilosaurus was not a reptile but actually an early whale, belonging to the order Cetacea. Basilosaurus was an impressive creature, reaching lengths of up to 59 feet. Its elongated body, streamlined shape, and powerful tail fluke made it a great swimmer. The structure of Basilosaurus featured a serpentine body and a long, narrow skull filled with sharp teeth. Its elongated form likely contributed to efficient locomotion through the water, allowing it to pursue prey with ease. The fossils of Basilosaurus were first discovered in the southern United States, particularly in Alabama and Louisiana, during the early 19th century. The first specimens were unearthed in the 1830s, with subsequent discoveries shedding light on the anatomy and lifestyle of this ancient marine mammal. It was discovered that Basilosaurus was a carnivorous predator, feeding on a variety of marine creatures including fish, cephalopods, and other marine mammals. Its sharp teeth and powerful jaws enabled it to capture and consume prey effectively. Basilosaurus likely employed an ambush hunting style, using its streamlined body and powerful swimming abilities to surprise and overpower its prey. Once caught, its sharp teeth would have allowed it to tear flesh and consume its meal. Both Basilosaurus and Megalodon were apex predators of their respective time periods. However, their hunting styles likely differed, with Basilosaurus relying on speed and agility to catch prey while Megalodon used its powerful jaws and keen senses to hunt large marine mammals. Number 3. Liopleurodon. Belonging to the group of marine reptiles known as pliosaurs, Liopleurodon was among the largest predators to have ever inhabited the oceans. It was a formidable marine predator of the Jurassic period and existed approximately 160 to 155 million years ago. Liopleurodon was truly impressive, with estimates suggesting lengths of up to 22 to 33 feet. Its elongated body, powerful flippers, and massive skull equipped with rows of sharp teeth made it a fearsome apex predator of its time. The structure of Liopleurodon resembled that of other pliosaurs, with a streamlined body, a short neck, and a large, robust skull filled with conical teeth. With eyes positioned to give it a wide field of vision, Liopleurodon could likely detect movement in the dim, murky waters of the Jurassic Seas long before its prey sensed danger. Some paleontologists believe it may have relied not only on sight but also on pressure-sensitive adaptations, allowing it to track vibrations through the water much like modern crocodilians. Imagine the sudden shadow of this massive reptile gliding beneath schools of fish, scattering them in frantic bursts as it closed in for the kill. Fossilized stomach contents and bite mark evidence suggest that it was not above attacking other large marine reptiles, potentially including long-necked plesiosaurs. In an ecosystem already dominated by giant predators, survival would have depended on both raw strength and strategic ambush tactics. The Jurassic oceans were a battleground of titans, and Liopleurodon stood at the very top of that violent hierarchy. Its powerful jaws and muscular neck would have allowed it to deliver devastating bites to its prey. Liopleurodon was a carnivorous predator, feeding on a variety of marine creatures including fish, squid, and other marine reptiles. Its sharp teeth and powerful bite would have enabled it to capture and consume prey effectively. Also, Liopleurodon's powerful swimming abilities and streamlined body would have allowed it to pursue and capture fast-moving prey with relative ease. Like crocodiles and their ancient families, Liopleurodon was likely a semi-aquatic predator, spending much of its time in the water but occasionally venturing onto land, particularly for nesting purposes. The fossils of Liopleurodon were first discovered in the late 19th century during the 1870s in France. However, it wasn't until the 20th century that more complete specimens were unearthed, providing researchers with a clearer understanding of their anatomy and lifestyle. Number 2. Zygophyseter. The Zygophyseter, a fascinating prehistoric sperm whale, inhabited the oceans during the Miocene epoch, approximately 9 to 12 million years ago. The fossils of Zygophyseter were first discovered in 1986 in Italy, specifically in the Pisco Formation of Tuscany. Zygophyseter was first thought to have been the ancestor of modern-day dolphins due to the fact that it remained quite small for a whale, but this is not accurate. Zygophyseter is indeed a member of the sperm whale family, Physeteridae, while dolphins belong to the family Delphinidae. Additionally, the assertion that Zygophyseter remained quite small for a whale is also incorrect, as Zygophyseter was actually moderately sized for a prehistoric sperm whale, reaching lengths of around 20 to 23 feet, with a streamlined shape, robust flippers, and a large, elongated skull filled with powerful teeth. When paleontologists reconstructed its skull for the first time, they were struck by how different it looked from the modern sperm whale, whose upper jaw lacks functional teeth. Unlike its deep-diving descendant, Zygophyseter possessed a full set of formidable, interlocking teeth in both jaws, suggesting a far more aggressive hunting style. Fossil evidence of bite marks on other marine mammals from the same formation hints that this predator may have targeted animals nearly its own size. Its muscular neck and reinforced skull structure indicate that head-on clashes between rival males could have been violent and dramatic. Some researchers even speculate that these ancient whales may have engaged in ritualized combat, using their tusk-like teeth to establish dominance within pods. In the nutrient-rich Miocene seas, Zygophyseter would have shared its habitat with giant sharks and other macropredatory whales, creating a marine ecosystem filled with intense competition and evolutionary arms races. The most distinctive feature of Zygophyseter was its upper jaw, which sported a pair of large, tusk-like teeth that protruded forward from the mouth. These teeth, known as the spermaceti tusks, were likely used for display and possibly as weapons during intraspecific competition. Zygophyseter was a carnivorous predator, feeding primarily on fish, squid, and other marine creatures. Its powerful jaws and sharp teeth enabled it to capture and consume prey efficiently, making it a formidable apex predator in its ancient marine environment. Its ability to echolocate and communicate with other members of its species may have also played a role in hunting strategies, allowing for coordinated attacks on larger prey items. Number 1. Helicoprion. The first fossils of Helicoprion were discovered in the early 20th century, around 1899, by Russian geologist Alexander Petrovich Karpinsky in the Ural Mountains of Russia. These initial discoveries included fragments of the creature's unique spiral tooth whorl, sparking curiosity and debate among paleontologists about its identity and lifestyle. At first, researchers struggled to even determine which part of the body the bizarre spiral belonged to, with some early reconstructions placing it on the creature's back or tail like a strange defensive weapon. Museums displayed wildly inaccurate models, each attempting to solve the mystery of the whorl's true purpose. For decades, Helicoprion remained one of paleontology's most confusing puzzles, a prehistoric enigma assembled from little more than a coiled set of teeth. It wasn't until advanced imaging technologies like CT scanning were developed that scientists could peer inside the fossilized spiral without damaging it. Those scans finally revealed that the tooth whorl sat deep within the lower jaw, tightly anchored and perfectly aligned for feeding. This breakthrough transformed Helicoprion from a misunderstood oddity into one of the most mechanically fascinating predators of the ancient seas. This creature of the ancient seas is believed to have roamed the oceans during the Permian and Triassic periods, which is roughly 290 to 250 million years ago. It belongs to the group of extinct cartilaginous fish known as Eugeniodontida. Helicoprion was smaller compared to the Megalodon, with estimates suggesting lengths ranging from 20 to 23 feet. The most striking feature of Helicoprion is its tooth whorl, a spiral-shaped cluster of teeth located at the lower jaw's front end. These teeth formed a continuously growing spiral, resembling a circular saw blade. This unique adaptation likely served a specific purpose in capturing and processing prey. Helicoprion's feeding habits have long puzzled scientists. Initially, it was thought to be a bottom feeder, using its tooth whorl to scrape or crush shellfish and other small prey. However, recent studies suggest a more active predatory lifestyle, with Helicoprion using its spiral tooth structure to slice through soft-bodied prey such as fish and squid. The hunting style of Helicoprion likely involved swift movements to surprise and incapacitate its prey. Once it captured its target, the rotating motion of its tooth whirl would have enabled Helicoprion to tear flesh and consume its meal efficiently. While some have assumed that the Megalodon might have rivaled with the Helicoprion, scientists have ascertained that it is far from true, since the time periods in which they lived also differed, with Helicoprion inhabiting the ancient seas millions of years before the rise of the Megalodon. Thanks for watching and see you in the next video.